Number 10, final problem looks a little difficult. 2 times the absolute value of n plus 1 equaling this 6n plus 6. Well, I know I'm probably going to get an extraneous solution. A solution doesn't work, but let's see. Starting this, I'm going to divide by 2 because it has something out in front of the absolute value. I need to get rid of it. So I need to get rid of it by dividing by 2. I'm going to divide this side by 2. So we're really looking for where does the absolute value of n plus 1 equal? Well, if I divide each of these pieces by 2, what do you get? 3n plus 3. So we're looking for, hey, where does that n plus 1, the absolute value of that, equal a 3n plus 3? So we're going to set it equal to the positive 3n plus 3, or when it equals the negative piece, the negative 3n plus 3. That's where we're always going to start it. Now let's solve it. I'm going to subtract n. I get 2n plus 3 is 1. Subtract 3. I get negative 2 is 2n divided by 2. N is negative 1. That's one possible solution. We'll come back and see, does it work? On this side, we need to distribute the negative sign through, which is really a negative 1. When I distribute through, I get negative 3n minus 3. I'm going to go ahead and add 3n to both sides. I get 4n plus 1, negative 3. Subtract my 1, I get negative 4. And that gives me a solution of n being negative 1. Which, here what's awesome, guess what? N is negative 1 or n is negative 1. I get the same solution. So the answer here is very simple, negative 1. Now we do need to see if I plug that in, is that going to work? Notice when you plug in negative 1 here, negative 1 plus 1 is guess what number? 0. Absolute value is 0. 0 times absolute, or 2 times absolute value of 0 is 0. When you plug in negative 1 here, that's negative 6 plus 6, 0. So yeah, in this case, there's only one solution, but both sides created the same one, which is pretty cool.